Welcome everybody to this demo that will showcase the potential impact of a CA compromise when that CA is stored in a Kubernetes secret in a Kubernetes cluster. A lot of service meshes that are out there and running on Kubernetes cluster store their CA in Kubernetes secrets. And what we found is that the governance and control of those Kubernetes secrets is not to the same level as the real secrets manager that are out there. Too many applications like cluster add-ons, for example, have free access to all Kubernetes secrets. Also, a lot of employees have free access to Kubernetes secrets. And this is something we encountered while working with our customers. And we are not alone who have encountered this. The Red Hat Security Kubernetes Security Report have shown that 26% of the respondents said that they have inadequate IAM access controls for their Kubernetes secrets and their Kubernetes clusters. This has far-fetching impact, and this can happen now already. We've seen like CVs come out that were able to let open source software get compromised, and that you were able to take over their Kubernetes service account and then gain access to all of the Kubernetes secrets. But we've also seen supply chain attacks to, like, for example, XAD utils, and nothing says that this will not happen to Kubernetes ecosystem. But this can also be like, for example, a rogue developer that's present in your company and that has access to all the Kubernetes secrets and might be able to gain access to then like that CA. Once you have access to a CA of like a service mesh, you can start creating your own certificates, impersonating the workloads that are running in that Kubernetes cluster, and completely circumvent any authorization policies that might have been in place to really go to a zero trust networking system within your service mesh. And this demo is going to showcase that. For this demo, we are going to use Istio as an example. But like this is the same applicable to all of the other service meshes that are out there. And it's not like a security issue with any of the service meshes. This is just like when you get your CA compromised, it's over. So I wanted to talk a bit about like the architecture that we're going to use for this one. So we're going to deploy a vanilla Istio inside our cluster that will have like a Kubernetes secret with our CA deployed into it, that one. And we have book info deployed with like authorization policies applied and peer authentication set to strict. Then we are going to deploy a rogue open source component that has a phone home functionality, which is, we call in this case, our poisoned controller. And that poisoned controller, for like normal open source things, like it needs access to all the Kubernetes secrets. This means it also has access to the Istio CA. The poisoned controller is going to read that Istio CA secret, and it's then going to create its own identity, or it's going to impersonate the book info identity. And with that identity, it's then able to connect to the details service, which is normally fully locked down, and only the book info can talk to that one. But because we have impersonated that identity, we're able to connect to that one. It also has a phone home component, so that like the attacker can, from the outside, enter to the poison controller and start running commands. So to showcase this, I have deployed a normal Kubernetes cluster. And I'm using kind for this one, and I have Istio deployed. You can see Istio D running in here, and we see here the Istio CA secret deployed. What we also have is the book info application deployed. So to start showcasing all of the impact is, first of all, I'm going to show how everything is secured. So first of all, we're going to get like the certificate from our product page. And we need to note down like that it's signed by our cluster.local, which is our internal CA that's stored in the Kubernetes secret. And also note down like the 8451 as like the authority key identifier. We also see that strict is enabled, and we have applied the following authorization rules. You can see like details viewer, product page viewer. The details can only from the product page. We have the reviews one, also only from the product page. And then the ratings can only be talked to from the book info one. This is applied to the Kubernetes cluster, and I'll show this as well. So these are applied and allowed. So like now we have really zero trust networking applied. So to showcase this, I have deployed a simple sleep pod in there, and everything at this moment can connect to the product page because that's where our customers come in and everybody can talk to it and we get a response back. But when I now try to do the same with the sleep pod, talk to the details service, I'm getting RBAC access denied, which is the default error that Envoy gives me back as part of that one. So now we're going to deploy our infected component. So this can be an open source component that had their software supply chain, or an enterprise tool even that had their software supply chain compromised. And some rogue code got into it. And because like it's a cluster add-on and to function well, it has access to all of the Kubernetes secrets. So first and foremost is it has like a bunch of extra code. And what's really important in there is it's going to read all of the secrets. And then it's going to, you can see here, read secret, CA secret is successful. And then it's going to generate a fake SPIFFE cert of the book info product page one. And it's going to do this every 5 seconds. And this is a simple bit of Golang code. We haven't really obfuscated it because like it's just for demo purposes, but like a real attacker would, of course, obfuscate is a lot better. So we can see that our poison controller is generating that SPIFFE cert every 5 seconds, and it's saving it to temp spoofed crypto. So what we're now going to do is we have also a phone home container deployed. You can see here, this is our phone home container, and this is our kind Kubernetes cluster. So our phone home runs outside of the Kubernetes cluster, but it has a reverse shell open from the poison controller. And we're going to then Docker attach to the phone home to be able to run commands within the poison controller, like a real attacker would do in like real life. So what we're going to do is like we're first going to run this curl command, this first red curl command, and that's going to fail. And then afterwards, we're going to run the green command with our self-generated SPIFFE certificates, with our self-generated certificates. And these are going to succeed. And I'm also going to showcase that we have been able to generate our own node. And then I'll show this here as well, is all namespaces. We have our poison controller running in here, and you can see like it only has one container, so it's not part of our service mesh, which is very important. Like this is to showcase that it's by default doesn't have access to our service mesh yet, and it's like just a cluster add-on running there, and thus like it doesn't have any preset permissions to be able to access anything within the service mesh. So now I'm Docker attaching to my phone home one, and this has opened the connection to the poison controller. So when I copy this curl command, you will see I get an access status 55. And this is because I haven't given it like my identity of my product page. And it's failing because like that's the service mesh doing its work and enforcing that everything is MTLS. But when I do a curl and I set the product page cert that I have generated thanks to my poison controller and thanks to having access to the CA, and then connect to the details one, it's giving me back all of its data. And I would be able to do this with very little knowledge of the environment I'm running in. I can start generating like just identities and then starting to crawl around and connecting to different microservices that might be running within my Kubernetes cluster. And to showcase this, like this is the product page one. And when I scroll a bit up, you can see this is also like with our 8451 signed. And this is the SPIFFE identity that's encoded in the certificates. And that's how like within the service mesh, the workloads are aware of each other. And when I repeat this now also for my CA cert, and I have access to this, like the public key is not like really private information, but like because I have access to the private key, I'm able to generate my own certificates. And this is how I do like the full compromise. And you can see this is our cluster.local and it's valid. And to know for sure that I have been able to compromise this is we have made our own certificates a month long, while Istio by default only uses 1 hour long certificate. So it really showcases that we have generated and issued this certificate ourselves, and they are not issued by Istio themselves. So to conclude is that we think like defense in depth is very important. Securing your Kubernetes secret by having proper governance in place and by checking if like only the appropriate people and appropriate software have access to them is very important. You also want to limit what people can run on their Kubernetes API servers. And you can use like policy controllers for that, like OPA, Kyverno, Cell, to limit what people and applications can do within the Kubernetes cluster. Also, applying network policies is very important because, like, again, that's that layer in depth, and that's potentially can prevent a lot of like these attacks already. And having proper runtime security in place. But like, as we are a machine identity company with Venafi, we also think you should keep your PKI in a more secure place than just Kubernetes secrets. And it needs to be highly available, and you need to be able to put it in a reliable place. And that's why we have created Firefly for this. Firefly is really able to run really close to your workloads, and we protect like the private key material. And we also make sure that the trust gets automatically distributed. And Firefly can be run in a highly available way and is very reliable component. I'm hoping with this with this demo that we've been able to showcase some of the potential impact of a CA compromise. If you have further questions, feel free to reach out to us and we will answer them. Thank you very much.